So I want to continue our discussion around slopes. And so today we're going to be discussing the difference between a positive slope, a negative slope, a zero slope, and an infinite slope, and what that will look like on the graph. All of the examples that we've looked at so far have been examples of positive slopes. And how do we know it's a positive slope? Well, we're going to see it increasing from left to right, right? So this is a slope that is going up as my numbers are increasing, right? So a real life example of that would be if you are going up, running up on a hill. So that's a positive slope. And so if you're calculating the slope of a given line using a graph, then you need to make sure that your answer, the answer that you get when you calculate that slope, you give a positive value to. Right? Let's talk about negative slopes. So you can tell that a slope of a line is going to be negative if it decreases from left to right. So a good example of that in real life is if you are going down a ski hill, right? So your elevation is decreasing. And so you need to make sure if you see that the slope of the line that you're looking at is negative, that beside the actual calculated value, that you make that value a negative number. So without doing any calculations, it's easy to see that a horizontal line will have a zero slope, right? So I can show you that mathematically if we just look at the equation for slope, which is rise divided by run, right? So if my slope is rise over run, then has this line risen at all? What is the rise of this? Well, the rise is 0, right? So no matter what number I divide 0 by, okay, so no matter what my run is, my rise is 0. And if you remember from earlier math classes, anytime you take a number, a 0, and divide it by any other number, you still end up with 0. Right? So some perfect examples of situations with a zero slope, or if you're running on a track, right? There's no incline there whatsoever, right? And the horizon, there's zero slope there. So again, if you see a horizontal line, you really don't have to do any calculation whatsoever. You know automatically that the slope has a value of 0. Where I have found that students get more tripped up is if they have vertical lines. Most students will forget that vertical lines actually do not have a 0 slope. In fact, they're the exact opposite of a 0 slope, right? You can imagine that if you have a tree does not have a 0 slope unless it's lying flat on the ground. It has an infinite slope, right? Because you'd keep going upward and upward and upward, right? If you have a sharp cliff, a straight edge of a cliff, that would also be a vertical line, and that would have what we call an undefined or an infinite slope. Let me show you how this works mathematically. So if you remember, slope, again, is equal to my rise divided by my run, right? So in this case, I see that I have definitely a rise. So depending on what 2 points I picked on my graph, my rise would be a certain value. So I would actually have a real life number there, right? But what I don't have is I don't have any horizontal movement. There's no movement side to side. So there's really what I would say is 0 run. Well, I don't know. You might want to take a minute to use your calculator here, but if you take any number, so say for example 5, and divide it by 0, your calculator will give you an error. And the reason that that gives you an error is because this is actually what we call undefined. So I'm just going to write UND for short, but your calculator will show error there. So just remember, we can't define a slope of a vertical line because it just keeps going and going and going. So to pull that together, you know, a positive slope is increasing from left to right. A negative slope is decreasing from left to right. A 0 slope is just a flat line. It's not there's no incline. and a vertical line has an undefined slope. So I'd like to just quickly go through an example with you to show you how to calculate the slope of a line where you see that it's a negative slope. Basically, the process is the same, and you can really go about it in a couple of different ways. So I'm going to show you your options. So one way to look at it is to say, okay, well, if I'm looking at this first point, my leftmost point, then to get to my next point, I have to go down, right? So that means this is negative. And in fact, I've gone down 1, 2, 3 units. So my rise is actually -3. But I've had to go over more towards the positive x direction here by 1, 2, 3, 4 units. So my run is 4. So in this case, my slope, just from the numbers on the graph, are -3 for my rise and 4 for my run, right? Another way to look at this is just to sort of ignore whether you're moving up or down or left or right, but just to say, okay, well, I know that there's a difference here of 3 units, and there's a difference here of 4 units, and I can see that I have a negative slope, and so I'm just going to use the numbers that I get and put the negative in afterwards. Either way, you're fine. I just want to remind you that if you see that the line has a negative slope, that either before or after when you do the calculation, that negative needs to be there. Otherwise, you have an incorrect value for slope.